Session 5 of the Numeracy lecture series, an introduction to concentrations, dilution, dissolution and concentrated waters. So we've spent the first 4 sessions doing basic numeracy, and hopefully those skill sets will now be used to do slightly more complicated calculations. So, if we just go through some background. Dissolution. Dissolution is a process of dissolving a material, so for example a solid, into a liquid. When the solid material is dissolved within a solution, the amount of the original material remains the same. However, the material is dissolved within the solution. So you take some salt, for example, and you put it into some water. You still got the same amount of salt, but this time it's not as a solid in a tablespoon, but it's actually dissolved in the water. So you then have a solution. This is usually expressed as a concentration. The larger the amount of the material dissolved within the solution, the stronger the concentration. So if I put 1 tablespoon of salt into 100 ml of water and dissolve that, that's a concentration of salt in that water. If I then put 2 tablespoons of the salt in the same amount of water and dissolve it, I've therefore doubled the concentration of the salt. So more the amount of material dissolved within the solution, the stronger the concentration. Dilution. Dilution is a process of making a substance less concentrated by adding a solvent such as water. So the amount of active ingredient within the diluted solution remains the same, however the solution becomes less concentrated. So going back to the salt and water solution that we made earlier, if I have 100 ml of water and I put in 1 tablespoon of the salt, I've made the solution, the concentration is as it is. By then adding another 100 ml of water, the amount of salt in that solution is still exactly the same, but the solution is a lot less concentrated because it's got more of the solvent, more of the water in it. So concentrations, therefore, concentration is a term used to describe how much of a substance has been mixed into another substance. This may apply to any mixture of chemicals, but usually refers to an amount of solute dissolved in a solvent. Concentration can be expressed in percentages, ratios and parts. Hurrah! Now you see why it was so important we did the first 4 sessions. So, for example, if we have 10%, that's the equivalent of 10 to 100, which means there are 10 parts of the solute in 100 parts of the solution. Or, because we can break that down further, that could read as 1 to 10, which is 1 in 10. So 1 part in 10 parts is a solute. Okay. Concentrated waters for today is what we're going to work on. Pharmacists have used flavoured waters for many years in the production of medicines. Many of these products were used to mask the taste of unpleasant medicines when we used to actually make stuff in the pharmacy for patients to consume. Nowadays, of course, modern day medicine means everything comes pre-packed, pre-manufactured, so there's less demand to make stuff. However, there are still cosmetic products, and there are still occasionally things that will require not manufacturing, but putting together. So some of these were used as a form of preservative. Some were used for cosmetic products. Commonly used in products, included chloroform, peppermint, orange, rose, anise, and lavender. And you will still come across all of these things in your modern day pharmacy. Chloroform and chloroform water. Concentrated chloroform water, your BPC 1959. This product contains 10% volume to volume of chloroform dissolved in water. So that means that 100 milliliters of concentrated chloroform water contains 10 milliliters of pure chloroform. So concentrated chloroform water is the solution. It contains 10% volume to volume of chloroform. So that's 10 in 100. So in 100 ml of concentrated chloroform water, you've got 10 milliliters of pure chloroform. Double strength chloroform water, this product contains 0.5% volume to volume of chloroform. So therefore, if you have 100 ml of double strength chloroform water, it means you've got 0.5 milliliters of pure chloroform. And lastly, single strength chloroform water. This product contains 0.25% volume to volume of chloroform. So 100 milliliters of single strength chloroform contains 0.25 milliliters of pure chloroform. What I'd like you to do now is work out the numerical relationship between concentrated, which had the 10% of chloroform, and double strength, which has a 0.5% of chloroform water. What is the relationship between those two things? One has 10%, one has 0.5%. So how are they related to each other? What is the relation to each other? I'm hoping you did 0.5 over 10, which gives you 5 over 100, so it's 1 in 20. The numerical relationship between those two is 1 in 20. In the same way, what is the numerical relationship between double strength and single strength? So double strength has 0.5% and single strength has 0.25%. So what's the relationship there? Simpler relationship there, it's a half. Okay? So, memorize this. There's no other way of doing this. If you don't understand how we got here, fine, just memorize this. But obviously I hope you do understand, because actually it's literally just looking at the amount of chloroform and the relationship between the two. But when making single strength waters, 1 part concentrate is added to 39 parts of water. So overall there are 40 parts. So the ratio is 1 in 40. So if you're making single strength, it's 1 in 40. 1 part concentrate, 39 parts water. 1 in 40. When making double strength, 1 part concentrate is added to 19 parts water, which means there are 20 parts overall and the ratio is 1 in 20. So double strength is 1 in 20, single strength is 1 in 40. It makes sense because the relationship between double and single is half. So if single strength is 1 in 40, double strength, which is half of that, is going to be 1 in 20. Now, just to make clear the in and the to, there's a difference. When discussing parts in and to, it's not the same thing. 1 in 20 is not the same as 1 to 20. 1 to 20 means you've got 1 part of concentrate and 20 parts of solvent. Therefore, it's a 1 in 21. There's a total number of parts becomes 21. So 1 out of those 21 is a concentrate. That's what 1 to 20 means. 1 in 4 means 1 part in 4 parts. So if you have 4 parts, one of those is your concentrate. 1 to 3 means 1 part to 3 parts. So total number of parts is 3. You've got 1 part and you're adding it to 3 parts. That's what 1 to 3 means. 1 in 4 means that you've got 4 parts and 1 of those parts is the concentrate. 1 to 3 parts means you've got 1 part of the concentrate to 3 parts of the solvent. So you're going to have 4 parts. It therefore then becomes a 1 in 4. So 1 in 4 is the same as 1 to 3. Despite these two ratios looking completely different, they describe the same value. Always use parts or ratios with the term in because they're much easier to work with. In my mind, it's a lot easier to say 1 in 4, which means I've got 4 parts and one of those parts is my concentrate. If I start working with 1 to 3, that's fine. I'm saying, okay, I've got to add 1 part of concentrate and 3 parts of solvent, which means I'm going to have a total of 4 parts. Already there's an extra stage there. If you just go with 1 in 4, it's the same thing. We're saying there's 1 part concentrate, 3 parts water, a total of 4 parts, but 1 in the 4 is the concentrate. Just to try and help the visual learners here a little bit, because this can be tricky, but understanding this now will be success for the future. So 1 in 20, that is 1 in 20. That red face, that red smiley face, well, part smiley face, is 1 in 20. There are 20 blue faces there. The red one is now 1 in 20. That little 1 to 20 would be this. That red face is now the 1 to 20. So you already had the 20 blue faces and you've now added the red one. So that's 1 to 20. That's the difference. So 1 to 20 is therefore the same as 1 in 21. The total number of parts is now 21. One of those is a concentrate. So that's the difference between in and to. So the only thing left now is to actually do some calculations to see how we would use these relationships and the 1-ins and the 1-2s. So how much concentrated chloroform water is needed to make 300 milliliters of double strength chloroform water? Have a go at this. You've got concentrated chloroform water. You want to make 300 ml of double strength chloroform water. Okay, so here you need to remember that the relationship between concentrated and double strength is the 1 in 20. So you therefore take your total amount that you're making, divide it by 20, and you get 15. So you're going to need 15 ml of the concentrated chloroform water to make 300 ml of double strength, because you're going to take 15 ml of the concentrated chloroform water and then add the rest of that will be, so 300 minus 15 will be the amount of solvent you add, and you would end up with 300 milliliters of solution. How much double strength peppermint water is required to make 350 milliliters of single strength peppermint water? Okay, now remembering here that the relationship between concentrated peppermint water and single strength peppermint water is the double strength peppermint water and single strength peppermint water is 1 in 2 because it's half. So all you have to do is 350 divided by 2 and you got 175 mils. How much concentrated peppermint water is needed to make 200 ml of double strength water? Here, remembering the relationship is 1 in 20. So it's concentrated to double strength, you divide by 20, you get 10. Concentrated chloroform water is required to make 600 ml of double strength chloroform water. remembering again, concentrated and double strength, the relationship is 1 in 20, so you do 600 divided by 20 and you get 30. Now, concentrated anise water contained in 1.5 litres of single strength anise water. So what's the concentration, what's the relationship between concentrated and single strength? Okay, this time concentrated and single strength, the relationship is 1 in 40, so it's, remember to convert it to millilitres first. 1.5 litres is 1,500 millilitres, you divide by 40 and you get 37.5 millilitres. So how much concentrated orange water in double strength orange water? Okay, so you've got 130 mils because you do convert it into millilitres, so you get 2,600, you divide by 20 and you get 130. How much concentrated orange water is required to make 1.35 litres of double strength orange water? Right, you've got the gist of this now. Concentrated to double strength, you're dividing by 20. Concentrated to double strength, you're dividing by 20. Make sure you get the millilitres in and you do the correct numerical calculation, so there are no mistakes in that. But the method is concentrated to double strength, you divide by 20. This one is concentrated chloroform water to make 3.65 litres of single strength chloroform water. Okay, so here remembering the relationship is the 1 in 40. So going from concentrated to single strength, you divide by 40. Again, doing the maths correct should get you 91.25. So, moving on to slightly harder questions. Just to recap what we've done, to go from concentrated to double strength, it was divide by 20. To go from concentrated to single strength, it was divide by 40. Well, you'd multiply if you were going to use the concentrate to say how much you're going to end up with. But if you had a solution and you had to work out the relationship, it's a 1 in 20 for the concentrate to double strength, 1 in 40 for the concentrate to the single strength, and 1 in 2 for double strength to single strength. So how much water needs to be added to 20 milliliters of concentrated chloroform water to produce single strength chloroform water? You've got 20 milliliters of concentrated chloroform water. You've got that. You need to end up with single strength chloroform water. How much water do you need to add? Okay, so now in this case, remembering the relationship between concentrated chloroform water and single strength, so concentrated and single strength is the 1 in 40. So if you have 20 milliliters of concentrated chloroform water, you would multiply that by 40 to work out how much single strength chloroform water you'll have. So 20 times 40 gives you 800 mils. That's how much single strength chloroform water you would end up with. 20 milliliters of concentrate gives you 800 milliliters of single strength solution. The question is not how much single strength solution am I left with, it's how much water do I need to add. So you can take the 20 away from that and that gives you 780. How much water needs to be added to 35 milliliters of concentrated chloroform water to produce double strength chloroform water? Okay, so again here, remembering that the relationship between concentrated and double strength is 1 in 20. So if I've got 35 milliliters of concentrate, I'm going to multiply it by 20 to tell me how much double strength I end up with. From that, I take away the original 35 mils of the concentrate, and that gives me 665 milliliters of water that needs to be added. Okay, so a customer asks you to make 16 liters of single strength solution, of rosewater solution for cake making. How many bottles of concentrated rosewater do you need? Each bottle of concentrate contains 200 milliliters. Okay, so again, looking here, you've got 16 litres is 16,000 milliliters. That's how much you need to end up with of single strength solution. So to work out how much concentrate I needed, I divide by 40 because of the 1 in 40 relationship. So I have 16,000 milliliters of the solution, single strength solution. I divide that by 40 to tell me 400 mils of concentrate is what I needed to use. I know that each bottle contains 200 milliliters, therefore 400 divided by 200 will give me 2 bottles. That's how many bottles of concentrate I need to make single strength solution at 16,000 milliliters. Prescription asks for 400 milliliters of a product to be made that contains 12 milliliters of single-strength chloroform water. You only have concentrated water in stock. How much will you need to use? Okay, so looking here, your answer should be 0.3 because you're doing 12 divided by 40. Going to do one last question. Prescription asks for 600 milliliters of a product that contains 25 milliliters of double-strength chloroform water and 20 milliliters of single-strength peppermint water. You have concentrated chloroform